In ultrasound imaging, color flow mapping has been extensively used in clinical diagnosis, which is based on the assumption of laminar flow. However, not only laminar flow, but also a more complicated flow can be discovered, particularly in pathological or curved or tortuous vessels. Therefore, this requires an advanced flow measuring method where both the absolute magnitude of the velocity and the flow direction should be obtained for an optimal diagnosis. On Mindray's new generation of premium ultrasound systems, the Resona 7, a novel ultrasound-based technology called vFlow is going to be demonstrated that can dynamically visualize the blood flow while avoiding the inconvenience of angiography. So rather than a series of static images, the fluidity will be displayed with dynamic arrows indicating the flow process. Both the magnitude and the direction of flow velocity can be measured at any location within the vessel. vFlow is based on the powerful ZST Plus platform, and it's using interleaved Doppler transmission as well as multi-directional transmitting and receiving technology. It breaks the angle-dependent limitation on traditional color Doppler, and meanwhile, the frame rate is significantly improved up to around 600 frames per second. As a result, vFlow is able to achieve millisecond level temporal resolution, which can then detect tiny, minuscule hemodynamic changes and display even transient phenomenon in the complex flow. And the arrows can intuitively indicate both the velocity, magnitude, and the direction, and this will lead to a more accurate measurement and analysis for vascular studies. Okay, so now we're going to show you exactly how this vFlow works, and you will be able to see for yourself just how easy it is to use this amazing analysis for hemodynamics. So the first thing we do is select probe. I'm going to go ahead and use the L11-3U. Okay, so I'll go ahead and bring up a carotid, and we will go from there. First thing you do is just bring up a nice image of the carotid artery. Then you will optimize the image. So you will optimize your color, your gains, your depth. And then the next thing I do is just simply select vFlow and start capture. Okay, so after I have selected the vFlow button and optimized the image using my region of interest box as well as the color gain and the depth, press the start capture key, and the acquisition time is usually around 1.5 seconds, and you can remove the transducer away from the patient. Now, it still takes a few seconds for post-processing because the frame rate is so high. Remember, up to 600 frames per second, and it's impossible for the human eye to observe all of the hemodynamic information with that high frame rate. So the system has to replay the cine loop at a lower speed for us. So once the post-processing has been completed, the system will then offer you two different ways for playback. The first is an autoplay, where you can select play automatically at varying speeds, or you can also select manually, which allows you to manually select the beginning and end frames as you desire. For software version 2.0, vFlow offers a series of quantitative analysis tools. These include wall shear stress, volume flow, velocity ratio, and velocity curve. These parameters can be important prerequisites for the early diagnosis, and also they can expand the diagnostic criteria for the evaluation of vascular disease. Now, let me show you how to carry out these measurements for more advanced vascular studies. The first one that I'll show you is called wall shear stress, and this is the friction which happens between the blood flow and the vessel wall. And this is the key factor for quantitatively assessing pathological changes. So the operation is actually very, very simple for wall shear stress. You simply just locate the WSS button on the touchscreen and select. Move the green icon to the specific location or spot to be measured. Press the set key and adjust the position so that the center line, the dotted line of the green icon, is aligned with the intima. And then adjust the orientation of the solid green line so that it is towards the lumen and perpendicular to the vessel wall. Press the set key again. Now, in traditional ultrasound platforms, volume flow is typically measured by pulsed Doppler. But now, with the vFlow technology, it's able to provide more accurate results. What you do is simply define a transverse section on the vessel, press select, and the result will be displayed for you. You can also measure up to 3 to compare the volume flow at different positions. So for the next measurement, we will discuss velocity curve. And for velocity curves, simply press velocity A, B, or C on the touch screen, and then select a specific point within the vessel lumen. Then the velocity curve will be displayed to illustrate the velocity change over the acquisition period. And you are allowed up to 3 points for simultaneous display. Lastly, after you've made your 3 selections, simply select Cine and Play, and the 3 variables will be displayed, the velocity change over the acquisition period. So the next measurement will be velocity ratio. And for velocity ratio, simply press the velocity ratio button on the touch screen and select 2 specific points in either of the vessel lumens or on the velocity curve. And then the velocity magnitude of these 2 points will be displayed, as well as the velocity ratio between the 2 points. You're allowed to select maximum 3 groups for the velocity ratio analysis. The next measurement will be velocity ROI, which stands for region of interest. And the velocity ROI allows you to focus on a particular region of interest. Once you click ROI on the touchscreen, it will show the max, the minimum, the mean, the median, and standard deviation velocity within the specific region of interest. Also, the green dot displayed here shows you the peak velocity within the region of interest. For even more accurate analysis, it's best to define a complete cardiac cycle manually. What you can do is click the VF button to define the starting point, and then click the VF prime button to define the ending point of the cardiac cycle. And to give you a quick illustration, here is the VF, which is the beginning point of the cardiac cycle, and the VF prime, which is the ending point of the cardiac cycle. So as you can see, the vFlow technology gives you so much more detail with different types of flow within the carotid artery, especially compared to conventional color flow mapping. Also, various quantitative measurements are provided by vFlow, and with further extensive clinical research This will highlight the real clinical value of using V-flow and will open new ways for investigation of the pathologies within the vessels. Thank you for watching.